Hello, today I'll be going over my exploratory data analysis findings for body type of Olympic runners. So we all know that athletes in different sports tend to have different body types. And by body type, I'm referring to the height and the weight of the athletes. For example, we all know that basketball players tend to be tall, and linemen in the NFL tend to be very big, as in they weigh a lot. And this is usually a factor of the success that they have in their various sports, as in not necessarily that because they have this body type they're good at the sport, but it definitely gives them an advantage in the nuances of their specific sport. So what we want to do is look at a data set of Olympic runners, specifically males, and try and see if we can find any trends in the height and weight of these runners to see if we can find an optimal body type for runners, similar to basketball or football or other sports. So the first set of data we're going to look at is the height of Olympic runners by event. And what we see here from this box plot, first of all, if you don't know a box plot, the box indicates the mean plus or minus one standard deviation, and then the little sticks indicate the maximum and minimum values of that data set. So here for the 100 meters, we have the box indicating the mean and one standard deviation away, and then the stick here points up to the largest value, which is Usain Bolt at 6'5", I believe. But what we see across all events here is a lot of overlap in the boxes, which indicates that there isn't a strong correlation between the distance of the event and the height of the athletes. So it looks like we see sprinters tend to be 6 foot or above, around that area, averaging around 6 foot, but we also see distance runners tend to average around the same height. So we can't really draw any conclusions that different event runners tend to have different heights from the data that we have. So let's move on to weight. Here on the weight data, however, we see a trend much different than what we saw in the height data. For the sprinting events, which is the events 400 meters and less, we see a lot of overlap. So the athletes in these sprinting events don't really tend to differ much in their average height. But once we reach the distance events and go up in distance, we see the average weight start to fall off. And all the way up to the 10K, we see a distinct difference between that event and the 100 meters and the rest of the sprinting events, where their standard deviations don't overlap at all. So what we can conclude from this is that there is a strong correlation in weight between the weight or the average weight of the athletes and the distance of the event that they run. However, the height and the weight alone aren't very good metrics for determining this correlation between event distance and optimal body type, because we know that height and weight tend to vary proportionally with each other. That is, we know tall people tend to weigh more. So what we're going to do is we're going to look at the weight to height ratio of these athletes and look how that data varies between the events. And what we see is a trend similar to what we saw with the weight data, where we see a lot of overlap with the sprinting events. But once we move into the higher distances, the weight to height ratio of the athletes start to fall off. So what we see is per inch of their body, the distance runners tend to weigh a lot less than sprinters. And this could be due to various complicated mechanisms of the different training regimens and diets that these athletes go through. But we can't really speculate on this because all we have is the raw data. But we can make correlation conclusions, and what this data shows us is that there is a correlation between the distance of the event and the weight to height ratio of the athletes, and that tends to decrease as the distance of the event increases. Another thing that we can look at in our data is that this is the success of these athletes in their events, that is the time that they run, and how this compares to the weight to height ratio of that athlete's. So if we see, or if we want to find an optimal body type of the athletes in each event, we should see a strong correlation between the athletes running a faster time and their weight to height ratio approaching a certain optimal value. So let's take a look at this data. So scrolling through this data, we seem to notice similar trends between each of the events. Is that we notice very small R² values, indicating that the correlation is low of the linear regression, and that's indicated by a very diffuse scattering of the data points. If there's a strong correlation, we would see the data points hug closely to the line and approach a certain value as the time decreased, but we don't really see that. We just see a diffuse scattering. The R² even approaches 0 for the 5,000 meters. What this tells us is that we can't really conclude that within each event there is an optimal body type, because if there was, we would notice a trend or a strong correlation in the data, where as we reach faster times, we would see, or we would expect to see, the athletes' bodies reach the optimal weight to height ratio, but we don't see that in any of our data sets. However, this could also be due to the fact that the data we're looking at is only for the Rio Olympic finalists, so we're only focused on a very small set of data that we know is the best in the world. If we were to say pool data from high school athletes as well and college athletes across all divisions, we would see a much greater domain of event times and a greater range of weight to height ratios. And what we would see in this data set is we would probably see a trend that we would expect to see, in that the large variation in ratios would start to approach a certain value as we increase in time. But once again, we don't have this data, so we can't make a conclusion on it. But we can still make our conclusion from the first set of graphs, where we saw that there's a correlation between the distance of the event and the optimal weight to height ratio of the athlete.